Is Rajneesh seen or Rajneesh not seen?
Yeah, Rajneesh isn't.
Okay.
കുഞ്ഞിനെ ഒന്ന് നോക്കൂ. 10 മിനിറ്റ് കഴിഞ്ഞ് ഇപ്പൊ ഇരുന്നു.
I'm seeing 15 participants as of now.
Yes, let's give folks a few more minutes to join, and yeah, maybe. Hey folks, so we are waiting. We are giving folks a few more minutes to join. In the meanwhile, I think what we'll do even before we get formally started is start doing, let's say, a brief introduction of folks who want to introduce themselves, what they do, how did they get introduced about LSPE, what is it that they're looking forward to learn from this, a bit about themselves. So just for a quick context, I'll let Devanshu talk more about LSPE shortly, but this is our first virtual meet. Given that everything is happening, we are also streaming it live on YouTube. We'll have the link updated on the LSPE meetup page as well, but we'll share it. So yeah, I'm Anshu Pratik. Right now, I work with a company called Grab. It's a Singapore-based transport / payment / delivery / whole bunch of other pieces company. So yeah, I've been with LSP since I was part of Yahoo earlier on. So I think it's about 6-7 years now running. So yeah, that's about me. I manage the site reliability engineering for Grab Financial Group, and yeah, have the honor to host this with Devanshu and Rajneesh and our speakers for the day, Roland and Arvind. Devanshu, do you want to quickly do a quick introduction, and maybe you can do an introduction later on once we start again, but yeah, just to keep folks on the line engaged.
Yeah, thanks, Anshu. So folks, this is our first virtual meetup, our 32nd meetup actually. We started in June 2012 and continuously operating for 8+ years now. So in our community, if you have noticed, we just crossed 2,000 members. So just before this event, and as you know, the motto being we share what we learn while we try to manage large distributed systems in our own organization. So basically sharing our experience so that each of us learn from others' experience. The primary motive for the community was obviously in-person meetup, but then humanity is right now seeing an unprecedented chapter of its history. So we are jailed inside our houses, or a little bit of movement allowed. So But we need to meet. We are a society. We are humans. We need to meet each other. So thanks Anshu and Grab for sponsoring this video conferencing platform, and so that we are trying our first virtual meetup today. So we have two speakers, and we'll start in another 5 minutes. If you have seen anything, any questions, or would like to do a short introduction of yours, please go ahead. Anyone like to talk, please raise your hand. Ashutosh, would you like to say something? Pradeep?
Yeah, I'm actually attending this after a very long time. Good to see that a lot of good works are going into it. But again, after a very long time, I'm attending it, so I'm looking forward for the meeting.
Thanks. Matthew? Subish?
Yeah, thank you for arranging this meetup, Devanshu. I am also attending after a long time. Thank you.
Great. Ankit Sharma?
Hey, Devanshu. How are you doing?
Yeah, we are doing great. Thanks for joining.
Yeah, no
you.
problem. Thanks for joining. And good to
Srinivas?
see everybody here.
Yeah. Srinivas?
Hey Devanshu, hello guys. It's been like first time, right? We are doing virtual thing. It's usually LSPE means meeting people and all that. This is a little bit different though. Let's see how it goes. I'm really excited to see what's coming up.
Great. Satish Dange?
Hey, morning, folks. Morning, Devanshu. Thank you so much for arranging this virtual meetup. Looking forward to learn something from this session.
Thanks Satish. Varun Yarama? Can you hear me? Hey, Ramki, I am seeing you after a long time. Ramki, would you like to say something?
Hey Devanshu, how are you? Lots of familiar faces and some new faces for me. Looking forward to see what's happening this weekend, and happy to collaborate virtually.
Thank you. Girish?
Hey, Devanshu. It was nice to get back to LSP after I think last meetup we didn't have. So it's nice that we are at least getting back virtually. I think we should keep it going. Be it virtual, physical. I think it's good to keep on the momentum.
Thank you. Pulkit Bajpai? Would you like to introduce yourself, please? Pratik Gupta?
Hi Devanshu. I guess this is my first time joining in this meeting, so quite excited to be a part of it. So
Yeah. So thanks, guys. I think Anshu, we are 10 minutes. So should we wait for another 5 minutes? I could see roughly 30 folks on here. I'm not very sure how many people are on streaming. Is there a way to see how many folks are actually using this stream?
Yeah, so we have 18 people, 17, 18 people out there on the stream as well, on the YouTube stream. Not sure if how many of them might be duplicated from here, but yeah, we have folks on there as well.
Okay, great. I think yeah. So another 1 minute probably, and then we could actually start with Roland.
Sure, sure.
Yeah, 23 here. So 23 plus, yeah. So usually roughly around 50, 45, 40 folks are there. Okay, somebody's connections is probably fluctuating a bit. I'm seeing 23, 22, 24. Okay, any connection in pending, Anshu? Joining request?
Yeah, folks are joining every minute, so
Okay.
I think we'll let them continue. Folks,
Okay.
so one quick thing about questions, given that we may not be able to have visual cues around of someone raising their hand. So even though Zoom does have an option of raise hands, we may coordinating that might be a bit difficult. So what we want to propose is that you can put in your questions in the chat, or we'll have the speakers take the questions end of their session. So doing it a bit slightly different, like typically in real life, we depending upon the speaker's comfort, we allow questions in between the session as well. Here again, rather than having interrupt the session in between, what we'll have that, hey, we can have the question in chat, we can have we'll have Q&A at the end of the session. So yeah, that's what is there at a high level. Any other questions from anyone before we start for the day? Okay. So yeah, Devanshu, you want to quickly introduce Roland before we get started?
Yeah. So good morning, everyone. Once again, a warm welcome for the first virtual large-scale production engineering India meetup. Our 32nd. We started in June 2012. So Roland is our first speaker. He works for Flipkart, and he would run through us with the automation they have to deal with really large-scale production engineering challenge. So over to you, Roland.
Yeah, let me quickly share my screen. I have a presentation to throw up. Please give me a minute while I do that. Okay, just hang on. I just got a beach ball when I click share. Yeah, that should be visible to everybody now. If not, please update so in the chat and we can see what's wrong. I also hope I'm audible. If not, if the audio drops, please update so in the chat. So I guess we are good to go. I'll start off. I'll be, as Devanshu said, he gave a brief intro. Let me add a bit to that. I've been working with Flipkart for quite some time now, about 5 years. I'm part of the internal Flipkart cloud team. We build and operate an internal private cloud for the rest of Flipkart engineering. And we offer a bunch of different services. As part of that, we also offer centralized monitoring capabilities. That's logs, metrics, alerts, and a little bit of non-functional business-like monitoring. We'll be talking. Actually, there was supposed to be 3 of us, but I guess due to the online nature of the current session, we may not be able to. All 3 of us won't be able to present. So I've taken the liberty of presenting on their behalf. And our focus today is to primarily look at what kind of use cases we have seen in our logging systems. And this would be primarily targeted to folks who might be looking at the build side of the build buy equation. But we also posit that some of these lessons might be useful to the buy guys too. Okay. So I'll quickly give a brief context of the tech environment in Flipkart. Yeah, as you guys might have heard, we are on Azure, but we are not. We build and operate our own DCs. There are 2 DCs right now. We sort of do our own hardware purchase and rack and stack and everything else that's required to set up a DC. And this DC is offered to the rest of Flipkart Engineering as a cloud, as a private cloud. That means you get similar constructs, you get instances, you get a load balancer, a software load balancer, to distribute your load according to a few policies across your service instances. And there's also a bunch of fundamental or other low-level infra services. For example, there's a common storage, there's an object storage service, and a few services to aid the development process. For example, a single software repository, a small build service, and it's not really a full-fledged PaaS yet, but there are bits and pieces here and there. On the app side, we typically see that users typically make their own tech stack choices, and whenever required according to their app needs. So it's not really mandated that folks have to adopt a certain tech stack itself. Having said that, it's not widely polyglot. We are largely a Java shop, and many folks end up typically using the Drop Wizard framework. So why I'm mentioning that is it typically gives you a standardized way to add your observability features, right, or your monitoring features through annotations and sort and those features. So that means we typically focus on monitoring at a app engineering level, not really at a business level. And we also are right now not really focused on the functional side of things, but really look at single apps, trying to improve the mean time to detect and the mean time to recovery for users whenever they hit issues. So it's a largely tactical monitoring platform rather than being a strategic monitoring platform. Yeah, when I said business monitoring, I meant product or business doesn't really look at the dashboards or the alerts or the metrics that are being surfaced through our platforms. Okay, so getting into log service, the log service proper. This is the term that we use internally, log SVC. We just call it log service. It started about almost 5 years back now. And the goals that were set at that particular point were to support both structured and unstructured logs with ad hoc analysis and dashboards on top of structured logs or semi-structured logs, and at least basic raw searchability over unstructured logs. These were the functional requirements. On a sort of NFR basis, the requirements were that, okay, this has to be near real time with a high degree of reliability and availability, primarily write availability. Right? I mean, of course, modulo infra failures, we can do only so much in terms of reliability. We didn't really aim for, let's say, 4 nines or 5 nines of reliability. But it meant that, yeah, the platform should be able to handle a certain rate and a certain number of infra failures that typically occur. These goals have not changed much over the years. They have largely remained the same. The evolution has been largely in terms of use cases, and then we see that a common use case that was cropping up again and again was cross-service event correlation across multiple services. And that's another use case that another goal that we took on to solve on top of this platform. Okay, so this is what the platform architecture looks like. I'll quickly run through this. This is in one DC. And it's replicated across in all the DCs that we have, which is currently 2, as I said. So on the left side, you have the deployment unit. I say deployment unit because today it's instances, and we soon are going to have Kubernetes orchestrated containers. So it's going to be a deployment unit over there that runs the app and then has a log agent which is in the form of RSys log today associated with it. In the instances, it's just part of the same instance. With containers, it can be a sidecar or it can be a daemon set in Kubernetes or the appropriate patterns over there. The way to read this diagram is to see the flow going from left to right. If you're looking at the diagram in front of you, it goes from your left to your right. That's the right flow. So the apps, the instances will hand off logs to array of syslog, rsyslog receivers, as we like to call them. And that is the entry point into the platform. I've also annotated the diagram a bit. The annotations can be read as wherever there is a vx.y, that's the particular version, current version of the component that we run. As you can see, we are running a lot of old versions. That's going to change slowly. The other annotation is how many instances are there at that particular layer. For example, rsyslog, we have around 90 instances. And the third annotation over there is what kind of instances we run over there. That means, again, rsyslog is largely stateless and it's pure compute, right? So rsyslog is the ingestion point, entry point. And that's also a first point where users can actually look at the log stream. So we provide a capability where you can do the equivalent of a live tail distributed grep across your service rather than maybe opening CSSH session in your terminal. You can achieve the same through an interface that provides the same capability. This is very limited because the amount of state that rsyslog carries is very limited, and the session is also very limited. So we typically limit it to a few MBs or a few, let's say, one or a couple of minutes. We don't really keep it alive all the time. And the use case over here is I just deployed something or I just enabled something. Let me see whether everything is okay on. This is another point where we can enforce admission control. Today, admission control is very limited. It basically does some amount of rate limiting. And the users can then can program the rate limiting or other quotas that they would want on the platform through the capacity manager. Yeah, so that brings me to a point that the standard logos that are recognizable are all open source components. The boxes are custom components that we have written and deployed. The two blue boxes, if you can see the colors, are control plane. The others are part of the data plane on the read and write paths. The horizontal line separates the querying portion from the ingestion portion. So after rsyslog basically stages the incoming log stream to Kafka, and from Kafka they get siphoned off into or rather pushed to a bunch of different stores. The primary stores today, there are only two. One of them is a near real-time store, which is basically a Solar index. And the other one is a long-term store, which is basically based on Hadoop. So the consumers will take the log stream that's coming in and then write it to these two particular stores. In Solar, the logs are exposed for search through a banana interface. And from Hadoop, we have a Hive component that exposes the logs as tables. The consumers is where the log stream gets separated out into different tenants. So the whole pipeline is multi-tenant for different apps or other different services. And the consumers is where the separation happens. And in Hive, we can search logs on a particular service basis. All right. There's another config component over there called as a config manager that provides capabilities for users to create custom indexes. So they can program on their log stream, if it's structured or semi-structured, they can program which particular indexes are of importance to them. And in Hive, we'll end up creating those particular columns for them. All this post-processing is done through a bunch of custom MR jobs that run on top of logs that get dumped into Hadoop. Okay, The rest of the talk today, will focus on some of the lessons that we, or rather some of the observations we have from analyzing our Hive queries. We won't be really focusing on the Solar query side, but we can talk about it later if folks are interested. Also, if folks are aware of Flipkart/N conference, the Solar, there was a talk presented about 5 years back or 4 years back for that spoke about a couple of the design aspects that went into creating the consumer or rather the indexer that would push logs to Solar. It's around a 20-25 minute talk. I would recommend folks go and look at that too. It's quite interesting. It largely talks about the scale involved in supporting a large insert rate into Solar. Yeah, that brings me to the kind of SLOs we provide over here. So today, this particular pipeline in one DC is capable of supporting around 2.5 million log lines per second. Each log line is typically 1 KB in size. The freshness, that is time to query for data, is at Solar is around 2 minutes, and at Hive is around 10 to 15 minutes. That's primarily because there's a bunch of post processing that happens over there. It's not really inline processing. And the query latencies are typical that you would expect with Solar versus Hive. Hive will convert a query into a MR job, right? So it has the associated latency with it. One other aspect is log retention. Again, that's left up to users. Typically, users retain logs anywhere between 2 to 6 months. Of course, there are outliers that want 6-month retention or even more. If nothing is provided, it's around 1 month by default. We see that works for most use cases. So at this point, we can ask whether this satisfies the goals or not. We largely say yes. We provide capability to create dashboards on top of structured logs through both Hive and rather primarily through Solar. And we can do ad hoc analysis through Hive since it provides a SQL semantic DSL. Okay, I'll move on. If there are any questions, please hold them. We can come back to them later. Primarily because when presenting, I don't really have a way to look at the chat window right now. Okay. So there were a bunch of decisions that we started off with, and some of the decisions got validated, and we also added a bunch of other design decisions to the architecture as we learned more about usage. One was that we decided to design for throughput. That meant write availability and ingestion throughput primarily. As I indicated over here, the app side would be around there would be around 50,000 or more VMs that would be pushing logs. So we wanted to be able to handle that incoming stream. So what that meant was we would look at scale out components primarily that can be easily scaled out, and components that don't require a lot of coordination in terms of design of those components as well as some of the internals. It also meant that if the components plus the custom components that we have, if they can operate in a shared nothing model, nothing like it, that will help us scale out a particular component just by throwing hardware at it. Yeah, there were a couple of other decisions for throughput. For example, we would not do a lot of inline processing, but operate in a slightly async mode. That's why Hadoop, the deep store that is built on top of Hadoop, would do post-processing of logs. Another design decision that became stronger for us was while we use Kafka as a staging layer and then destage logs from there, it is pretty much invisible to everybody else. We don't really offer it to users to write logs to Kafka directly. Rather, they go through rsyslog. Similarly, Hadoop does not consume logs from Kafka directly. They get destaged and written to raw HDFS first, and then the custom MR jobs will post-process the logs over there. This gives us a benefit that a job failure or a laggy job does not really crash the cache on Kafka. if there is a bug or if there is a transient network issue or a hardware failure or anything that affects the read-write load on Kafka, we want to keep that stable as much as possible. Then from an ops point of view, we again adopted a bunch of practices, and we see that many folks in the industry are similarly adopting them, maybe under a different name. Today, what sometimes gets called as GitOps, we basically said, okay, don't run anything manually. Everything has to be checked in. If you're running one-off commands, those two have to be part of a script that can be automated. That is, avoid any manual operations on the cluster. Automate and script that out as much as possible. It may not be pure declarative like most GitOps principles are today, but it is more like, okay, whatever operations have to be performed in the cluster are committed to Git, right? That there are scripts for that, there are runbooks for that, and they have to be strictly followed. So we don't want to really diverge from that. If there are changes required, let's update our scripts and our runbooks first. It also means that we will log all operations. This primarily helps us, and that log is also sort of maintained in Git itself. So that allows us to go back in time and then find out what really went wrong, if some deployment or some config change went wrong. And there were a bunch of other disciplinary, I won't say disciplinary, but that self-imposed discipline that we followed, as in we have alerts, right? And we don't want to really look at dashboards every time, but we adopted a practice that we will look at dashboards once a day just to be aware of trend lines. That will allow us to see if some components are deviating from the normal slowly. And that practice has helped a lot. For example, as hardware aged, we started seeing that Kafka persistence when it used to flush data to disk was taking longer and longer. Right? We could have set an alert on, let's say, disk IOPS utilization, but that might have triggered when it was too late. But just eyeballing those dashboards on a regular basis helped us detect a possible problem. Another I should say fallout of these ops practices was that we adopted a lot of defensive programming practices even in the ops world. The goal was that we can assume that the operator has woken up at 3 o'clock in the night and it doesn't want to think too much, and we should not impose cognitive load on him, right? And he should just be able to follow a standard runbook. And if he does fat finger something, then the scripts would catch it. For example, we don't want to resize a component down, and the ops operator, or rather the SRE, has to be really sure that he wants to resize a component down. The scripts will not allow him to do that. This catches cases where you may, when instead of saying 10, you may miss out the 1 and then resize it down to 0, right? Another fallout of this was that if it's all well standardized, right, anybody can do maintenance. That meant even the manager, if required, can do maintenance. And you don't, that the learning curve for cluster operations becomes smaller. Yep. So moving on, this is a large chunk of the talk. We try to look at how user behavior has been over the years. For today's presentation, we have taken a small sample, representative sample of analysis of the query patterns at the Hive layer for 3 months. That is over the first quarter of this year, Jan, Feb, March. And we present some analysis, and we can talk about that if some of this analysis is possibly in the wrong direction. So the first observation was that we see a lot of long tail distributions with respect to user behavior. I'll explain what that means. I have a few, actually very few graphs, plus a bunch of numbers to explain that particular point. Before jumping into the read path, let's talk a bit about the ingestion payloads. Ingestion payloads have largely remained stable, even though we still see a long tail distribution over there. So most log payloads are in the 1K to 2K range. There are outliers where logs might be, a single log line might be in the 10 MB range or even more. And those were usually detected and then resolved to be user end bugs where they were not really pruning their log payload, or rather I should say they were logging, collecting the responses from a lot of downstream services and then logging all of that. That would generate sometimes even 100 MB payload, which was obviously not really required. Or it could be split across multiple log lines. So there were a few outliers there on the ingestion side. And in terms of ingestion rate, it's pretty standard. Ingestion rate, at least in the logging world, is a function of your incoming load, right? Unlike metrics, which are relatively stable. Over here, we see that during BAU, that is business as usual conditions, there is because Flipkart is primarily an e-commerce product, there is a daily pattern to it. It starts picking up at 8. It really sort of picks up at around 10 o'clock in the morning, and then there is a nice sine wave that goes on, and then from around 8 in the night till around 6 in the morning, it's pretty much dead. Right? Then there are these one-off events. For example, Flipkart used to run a flash sale every Wednesday. That is when ingested logs used to really spike at around 12 o'clock. And BBD would introduce slightly different behavior because there was a program of early access, right? You would open sales to a special set of customers at 8 o'clock instead of 12 o'clock in the night. That is when we used to see elevated load on our platforms. This is all, of course, expected. Nothing out of the ordinary. What was really unexpected was the way users used to really provision ahead for their ingestion capacity. We see that users are not able to really do that. And I'll also buttress that point in the upcoming slides. Okay. As I said earlier, retention is typically between 2 to 6 months. It does not really diverge from this. The common case is 2 months. There are a few outliers at 6 months or more. Okay. Out of the queries that we analyzed at around 6,500 queries for the first quarter of the year, and we looked at a few axes on those queries. One was the duration of, or rather the time range of the query, and that was a primary goal because we wanted to validate assumption with respect to whether long-term retention is required or not. So we saw that around 60+% of the queries, that's roughly around 4,000 queries, would look at logs for a single day. That is, the query they would run would be show me logs where date equal to XXX. When looking at older logs, they would just change the date. Right? And they would go back and around P95 of those queries would go back as far as 2 months and not beyond that. Actually, slightly less than 2 months. So that meant that they would run the same query again and again just by changing the date. Then another fraction, around 2,000 odd queries, would be looking for a date range. So that was an improvement over the first pattern, right? And they would look at and around P95 of those queries would look at a date range of around 20 to 25 days. So that meant that this guys was sort of doing more work in a single query compared to the first set of users. So what does this tell us? It probably tells us that user education has to improve. Maybe it is not really intuitive that you can really query date ranges easily. And another suspicion or other that we have, which has not been really validated, is that a large fraction of these queries are probably automated through some sort of a cron job at the user end, where they just extract the data and probably do offline analysis. Okay, this is another aspect of user behavior. We try to determine from a on a tenant basis, how many logs were being, how much data was being stored and how much was being queried. So on the left side, we have a user versus stored logs pie chart that primarily says out of the data retained, total data retained, around a third was from a single app or a single user. And the next two users would account for another 1/3, and everybody else was the remaining 1/3. And contrasting this with the number of queries that were being run, we saw that around a fourth of queries were run by a single user. By the way, the colors don't really indicate the same app. So the blue 24% on the right side is not the same user as the blue 33%. So the user, the app that was storing those logs actually falls below, in terms of query count, falls below 5%. There was one more data point we wanted to present. We could not complete that analysis. That was, you have stored this much data. How much of this data is actually scanned during your queries? That we could not complete. Otherwise, that also would have been an interesting data point to note. Okay. So after those sort of quantitative aspects of user behavior, we also tried to understand some amount of qualitative aspects of what users really wanted in terms of querying as well as ingestion. And here are a few common use cases that typically crop up. One is users want everything, right? He says, I want to continuously, that is in a streaming mode, send large logs, which you should not sample and you should not drop, and you should retain them for 6 months, right? This does not really fit into the classical engineering debug use case, right? So we can break this down. For example, continuously means what? As in, do you have logs stored somewhere and you want to do a bulk ingestion? No, I'm generating a continuous log stream and just siphon it off. And large logs, as I alluded to earlier, some users were basically collecting request response payloads from a bunch of services that they were interacting with and then logging that. Rather than relying upon logs that the other services might generate, they were taking a paranoid approach and logging those responses too. The aspect that a log should not be sampled, not dropped, possibly points to the fact that they are not really using this for debug, but for another purpose. And the long-term retention also points to a similar requirement. Right. In addition to that, there were other users who basically wanted to treat the platform rather as a storage platform rather than as an analysis platform. They wanted to just dump the logs and then be able to just download all of them for separate analysis by themselves. There were various reasons for this. Many of them wanted to take those logs, structured logs or otherwise, and maybe ingest them into a different analysis too. Some of them users were more like, okay, I'm not really comfortable with Hive SQL. I am more comfortable with a different analysis tool. I rather want to use that. There was another use case which sort of points to a solve for problem number one. They wanted to trace how a particular functional entity, for example, let's say a product ID. If you're looking at a particular product that is being listed on the Flipkart platform, they wanted to see what all has happened to a product ID across all services. And they wanted to see the functional flow for that particular entity. And they wanted to present this as saying that, give me code tracing, a la Zipkin or Jaeger. And then when we used to get back and say that, but that will have built-in sampling. But they said, no, we don't want sampling. That again pointed to that, okay, you don't sample, but give me the equivalent of a trace through the services, right? And one more class of users was where they were doing something that we call test in log. Let's assume you have a function in your code that has around 4 or 5 decision points, right? If else conditions. They would log each of those points and then look at logs to see how the function was behaving. So that's as good as testing a function with different inputs through the logging system. They could have very well done this on the local box too, but they were trying to do this on an aggregate basis across all their services. So we tried to collapse these use cases into a fewer set, and we sort of came up with the requirement that what users probably want is a equivalent of a functional audit of their services. I push certain entities in my microservice collection, and these could be different patterns, right? The services could be REST-based services that interact synchronously, or they could be there could be async communication patterns between them too. They might just send an event through Kafka or through another mechanism to other services, and then they don't really have to wait for a response. But they don't have a good way to tie the transaction together. So they wanted to tie that at an entity level, right? So that meant they wanted to be able to audit the whole microservice collection at a functional level. And then they wanted different views on top of these events that they were sending to a logging platform. One view was to take a good example. Was that for example, as I was talking about a product catalog, right? When a product catalog gets onboarded onto the Flipkart platform, it goes through a bunch of processing. The data has to be cleaned, it has to be normalized. Then there would be ranking that would be applied on products. Then when some user searches for it, the search pipeline would take inputs from different other different platforms in terms of serviceability of a particular product or serviceability of a particular seller, right? So when they were sending these events across their different systems, which had a async communication pattern, they wanted to see how many of these entities would be processed here and at, let's say, microservice A and not at service B. And because you don't have a sync communication pattern that gives you an idea about failures, you have to look at that log collection and then figure out, okay, maybe count number of events processed here versus count number of events processed there, and then see if there is a mismatch, right? So they wanted to do this automatically. That meant, okay, can you give me a report across the logs events that you have ingested? So that again points to a functional audit kind of use case. Yet another use case was when I push a particular entity, this would be typically to support a on-call debug use case, right? For example, a seller might come and say, I've been trying to sell red shoes, but whenever I search for red shoes, my name never comes up. What's going on, right? So then the search team or the product team would look at, let's look at what all has happened for this particular listing or this particular product. That meant they wanted the equivalent of a doc view over a large retention period. Maybe the product was ingested, that catalog was ingested about 2 months back or 6 months back, right? And since then, what has really happened? So they wanted a document on a single entity. So this tells us that folks want different indexes on different keys if they have a structured log, that is. So, and again, all this comes back to the point that people are treating an engineering debug platform as a functional debug platform and a functional audit platform. So that is why we ended up adopting that other use case that I mentioned earlier, where we started building a cross-service entity correlation capability on the existing pipeline. Okay. I'm pretty much done. The last slide that I have is about what we are doing next on this particular platform. To further support functional debug use cases, functional monitoring use cases. For example, reports. We are looking at windowing capabilities over log streams and alerts on top of those. And alerts on different time ranges. Different users want alerts on different time windows. Another use case that users typically ask for is some amount of predictive analytics on top of system behavior. May not be functional behavior, but system behavior. That meant the use case that we ourselves face, right? Can we make a short-term, may not be a mid-term or a long-term prediction, but a short-term prediction about possible alerts being triggered just by looking at logs that are coming in right now. Of course, the other use case, as I mentioned, users look for is pure classical distributed code tracing in the style of Zipkin or Jaeger. In addition to this, we're also looking at building some platform goodness. For example, if you had paid attention to the counts, we have a lot of instances. We want to optimize that, maybe reduce some of the costs that we incur in terms of infra. And one way to do that is to look at separating a compute from a storage, particularly at the HDFS layer, right? For example, data nodes don't really require a lot of CPU, but they require a lot of IO. That means they require a lot of spindles. And the jobs that run over there, today it is possible with high-speed DC networks that you can run your yarn containers on a different set of instances and your data nodes on a different set of instances. That means that I can scale up my yarn containers up and down based upon load, better in response to load, rather than provisioning for peak capabilities, peak throughput. Another aspect of this is that we typically see a lot of asymmetry with respect to read and write, right? People are sending more logs than querying. So that means that can we size our pipeline to be minimal for handling write workloads and look at elastic scaling for handling read workloads. That is why I called it Elastic Search as a intended pun. Maybe we can look at spinning up yarn containers on demand for user jobs, that is on Hive query side. And maybe on the Solar side, we can look at spinning up a small ES cluster or another Solar cluster just for temporary analysis for certain users. Another problem that we face is, as I said earlier, users are not able to predict their required capacity and reserve that upfront. That is because there can be various problems there, right? I mean, typically business tells them scale your platform to handle so many orders per second, let's say. There's no good way to translate that to downstream infra requirements. So we are saying that rather than you telling us how many logs you need, we'll say that, okay, you have probably sized your platform to X. And if you are let's say, running at peak capacity on so many instances, it should translate to a function in terms of how many logs and metrics you would be sending. And we will size that and reserve that capacity for you equivalently. Rather than leaving it to users, we can take that call on their behalf. These things are in progress right now. They are in sort of early stages to mid stages of implementation. The last set of use cases that we want to build for the future is what I've called as one log service. As I mentioned, we have multiple DCs, right? And we are also moving towards thinking of moving towards a hybrid infra model with burstability to public clouds, let's say. Now, if I want to provide a unified view of monitoring across multiple DCs, multiple DCs plus the public cloud, we should be able to support, have a presence there, maybe, or able to support ingestion from maybe non-standard infra or other. When I say non-standard, I mean not the usual infra providers. Another point that leads to is we can extend the same to regular metrics too, right? We want to provide a single view. And while we're at it, can we adopt a honeycomb-like approach where we say that, okay, you send wide events. So we say, okay, rather than users adding annotations to each and multiple annotations to their function, right? Typically they say this function they add let's say in drop wizard, you add a bunch of annotations that say that, okay, you have to add JMX metrics for this particular function. And JMX will translate that to maybe around 5 different metrics to be emitted. Similarly, for logs of a code tracing, they'll add a bunch of annotations. Rather than adding multiple annotations, can we add a single annotation? And that will provide all 3 views for you. There are already industry efforts in this direction. We are looking to adopt some of those efforts, right? So that's what we call as our events first philosophy. Also, we are still focused on app monitoring, right? Those were our initial goals, app monitoring and system monitoring. can we elevate our monitoring to something that is closer to business, maybe functional monitoring that users are already doing, and provide better first-class support for such use cases, and maybe even provide views that can be converted to support business or product stakeholders. So these are again in early stages of design, I should say, or at least product thinking. We are not there yet, but that's what we are trying to aim for. Yeah, so I'm done here. I think I'm sort of on time, exactly 40 minutes. I'll probably look at questions now. Let me figure out how to look at questions.
Thanks, Roland. So there were a couple of questions on chat. First question from Satish. Sorry, first question from Girish. When you're talking about log retention of 1 month, is it on Hive or Solar?
Yeah, sorry, I was not clear about that. On that log retention of 1 month or more applies to Hive, not really Solar. Solar retention is very low right now, even though it's a largish cluster. We retain logs for only about half a day, so that the Solar endpoint serves for near real-time debug use cases, with Hive meant for longer debug use cases where you come back a couple of days later and then say, okay, let me go and see what really happened.
Okay. Devanshu, I didn't even ask if there was a graph in the slide, which I think shortly thereafter you had showed some diagrams. Question from Satish, do you use physical hosts or public cloud? And if public cloud, which one?
No, as I mentioned earlier in the beginning, we have our own DC. We have a DC team that maintains that, rather maintains, builds, operates a DC. And we have as part of our cloud platform team, we have an infrastructure team that converts that DC into an internal cloud for us. Our instances are sort of based on KMU KVMs right now. It's not really physical hardware as such. And no, we are not really on a public cloud yet. It's a bare bones private cloud based upon VMs today.
Okay, yeah, Darshan had tried to answer that question. And one more question from Darshan. During your query analysis, how many of the queries needed a full text index like Solar? An alternative would be to index just some tags, example, log level response on the logs and query on those example Grafana Loki. This would be much cheaper too. Wondering if you evaluated this.
Yeah, right. So query analysis shows us, I think I missed that point. Looking at the 3 classes of user queries that we have, we can look at, there are roughly 3 classes. One is the first class, and these are equivalent in size. One class is where they do equivalent of a graph, where they say, show me all events where a key like this is present, or other string like this is present. That's like equivalent of a full text search, right? The second class is where they want to look, and this is largely applicable to users who send structured logs, where they want events where a particular key has a particular value. So they may say where product, as I was saying earlier, product ID equal to XXX. And the third class of queries was basically show me everything that you can, right? So they would just say that show me all logs for a particular time range or for a particular day. And then they would probably look at offline analysis for that, or try to download that in some form and do their own analysis at a later point. So yeah, we have not really closely evaluated the other platforms. We have primarily because we are continuing our investments in the current platforms that we have, that is Solar/ES. It's largely Solar Cloud today, as well as Hive. We see value in the other platforms, but we don't have formal plans yet to adopt the other platforms that I mentioned, for example, Grafana or Loki. We do use Grafana, but that's mostly on a metrics pipeline, not on a logging pipeline.
I guess that's all the questions on chat. Folks on the call, any other questions you have, you may want to bring in. Okay. Ending this session in 5, 4, 3, 2. Okay. Thanks, Roland. So yeah, for this session, feel free to keep adding questions in the chat. We'll see if either we can take it the post session or maybe on the meetup group. Yeah, Devanshu, are you there?
Yeah. So thanks, Roland. It was nice. Actually, the first session was pretty decent. Audio was clear. Video was clear all the time. I think all the people who were here, roughly, I think max we saw 32.
Yeah. So there are 30 people here, 30 people on the YouTube stream. Just to quickly interrupt, I think 2 more questions came in just when I said that. So second last question from Ankit. Where in the pipeline are devs able to stream logs for more than half a day?
So they don't really stream it. We don't offer a live stream of logs. As I mentioned, there's only one place where you can look at a live stream of incoming logs, but that's for a very limited amount of time, only a couple of minutes. But you can query over larger time periods at the Hive endpoint. And depending upon the amount of log information, we do also allow capability to extract those logs for offline analysis. We typically limit that to a few MBs, or rather, I won't say few MBs, a few tens of MBs, not even 100 at 100 MB.
Okay. And follow-up question from Darshan. Thanks. This is tangential. What does the metric platform look like? If Prometheus, how are you scaling it?
Okay, I'll try to quickly answer this. We are not on Prometheus. Again, our metrics platform was built at the same time as the logs platform. It is the same team, and the platform architecture looks quite similar. There's ingester, which is again RSS log based, that stages metrics to a Kafka, and from Kafka they get pushed into OpenTSDB. And from OpenTSDB, they are surfaced through a Grafana UI endpoint. We are not on Prometheus. We did evaluate Prometheus. The thing being, Prometheus scale-out efforts are still in early stages, and those are not yet stable. Right, so we are not looking at adopting Prometheus yet. We are rather looking at adopting maybe I would say the big win that Prometheus gives over, let's say, something like OpenTSDB is 2 things. One is the hypercardinality support for larger dimensions with rather more number of dimensions with more number of values. OpenTSDB also supports that. We have just not upgraded over there, or we can also look at implementing the Gorilla paper that presented this particular idea. And the other big benefit is PromQL is really awesome compared to the basic, I won't say basic, compared to the querying capabilities of OpenTSDB. We are considering adapting or rather providing a PromQL query engine, layering it on top of OpenTSDB, but we are not. It's still again in early design phases. It's not yet something that is in production or even testing.
Okay, thanks. I guess that answers the question. So yeah, Devanshu.
Yeah, thanks. So Anshu, so one thing is coming in my mind. If we can all club all these questions from the chat room and put in our meetup group, and then let Roland go there and answer, keep those answers, so that the YouTube streaming viewers also have an option to come back and see it is in a documented manner. That could be good.
So if I may suggest, anyways, I guess the presentation will be uploaded, right? I can create a doc with the questions and the answers and then attach it together. Would that work?
That would be great, Roland.
Yeah.
Okay. Okay. So I think we have time to get Arvind in. So over to you, Anshu, to change the presenter.
Thanks, Devanshu. Arvind, are you there?
Yeah, great. We'll kickstart. So shall I start sharing? You should be able to see the screen, right?
Yeah, I can see it.
Or I don't have the chat window here. Maybe, yeah, maybe if there are any questions, Anshu, like please feel free to stop me in between and show some stuff there.
Sure.
I'll also try to see if there is anything in chat. Okay, great. So welcome everyone. Thanks for joining the session. I know it's really a tough situation, and personally for me, a lot of crazy things are happening back home as well. So yeah, coming to the session. So I've done this session a couple of times, but I'm trying to do something really different today. Like trying to show something, build the demo, the entire demo here right away, so that you know what, how it is easy to like get started with all of this. I appreciate like Roland sharing a lot of info about how they have built a logging service. It takes a lot of effort to build something really scalable and something for a really large scale web service like a e-commerce service. So today we'll do a bit of observability intro, and then like talk about how we solve the problem, what are the various approaches that what we notice with different community users as well as customers. Then also like I'll talk about something called elastic common schema, and then various other details about common schema and what are the modules. I'll also give an intro about what are the things that are coming in, and then like I'll try to show you a demo. So that being said, I really don't want to like waste a lot of time. So if you are already into like trying to create a platform like observability, I know this is not like a regular meetup where I could ask questions and like do stuff like that, but then like I'll take some assumptions and try to do it in intermediate way wherein like everyone gets their thing. I know if you're experienced and if you have already heard some of this, sorry, but I was not doing that. So hello again. Thanks for joining. I'm Marvin and I work at Elastic as a developer advocate. And I also like take part in some of the conversations around special interest group contributor experience for Kubernetes. Kubernetes, as you know, is a very popular container orchestration platform and an open source project. So take part in the community organization. If you are really interested in contributing to Kubernetes, please let me know. Of course, it could be as simple as like trying to edit a document that you feel that is not right or that you could improve developer experience for somebody else who is building on Kubernetes. So please let me know if you have more questions on how to get started. I'll help you with that. Uh, but then my DMs are always available, so you could also do that. Okay, again a question. So yeah, this session, whenever I kind of do it online, it's kind of ask a lot of questions, understand what users were like, and what they think about production systems, maintaining, managing, monitoring, doing a lot of things around real world production system. What are the things that they face? Some of it is also taken from our SRE team or infrastructure team. I'll try to show you what our cluster or what our exact view of how do we build entire things on apps like on Kubernetes. But then I believe like quite a few are, because this is a large scale production engineering group, I believe that quite a few are already like into the maintaining, managing, or monitoring, or trying to help people who manage these production systems. So that being said, I know that quite a few people release the software or do releases on weekends or Friday. So I try to take it a story kind of a thing and try to explain you how or why this is important. Say like something like monitoring, managing, not that part of what, but like, what is this new word called observability, and how it probably helps a lot of people. And one important thing that Roland as well said is like cross event correlation. Cross service correlation in the microservice world. So basically, quite a few people, when they kind of like get started with the any platform, they tend to want to find out things or want to find out what are happening in the real world production system, and try to figure out things from the signals, and then give fixes to that, so that the business continuity continues to happen, and then they don't face any problems. So similarly, in such case, suppose you see errors like these, like say you tend to see that you tend to open logs, you tend to try and fix, find out different problems that are arising out of your system, and using monitoring tools, and find problems. Or in like when you try to like fix a bug in the production, see, this happens pretty much in the cloud world, wherein we see a lot with several users, wherein they or on our Discuss platform, wherein people want to solve bugs on the fly, but not being able to upgrade to a latest release to solve the problem in one single go, but want to really fix a bug and identify that in a quick manner. At the same time, like when you start firefighting all of this, and you try to somehow fix this one, you some people might not be able to do all of this, and like they will still face issues like performance lag, or say how probably not, logs not showing up in the platform itself because the platform is down, and you don't have awareness of how the platform is running, because like availability, you're not able to you're not able to collect availability. Then you probably might do ping the IP address and see whether this particular service pod container is up or not. So there's another dimension or way to look at things. And then we all open all of this and then try to see, explain, and find out and fix. So this is what we call as a moment where in any developer life, I've been there for multiple times, where I did a small change, and then due to the semicolon that didn't go through into the code, and the page starts crashing, and then the service doesn't respond, or the users see different messages, a lot of problems. So basically observability, like I think we might have seen this slide quite a bit of time by different people. And then basically observability is like unifying the logs, metrics, your traces, or even your uptime, the availability. There are other vectors or something like that is being added again and again now. See, just like in Hadoop platform, you have people now also to think about synthetics, or like real user monitoring, finding out and trying to unify this entire experience, trying to show functionally for the business, say that, okay, this is how things has gone wrong, and this is how we want to fix, and this is how it has impact on the business. So the end goal is always to have continuous safe, reliable platform. So observability is one such keyword that has not really come up. I mean, it's really a buzzword. I think like quite a few people say that it has started from a blog post in Twitter. They used to use microservices, and there are different architecture paradigms that they have taken and finally got into this sort of a place. But then it is not really new. At the same time, it is not the same as monitoring. So if somebody would have said that monitoring and observability is more or less, I would debate about it. There are similarities, but observability is more or less not just like monitoring a black box. It's also like understanding your programmatic flow and relating it with different components, and also like finding out the functional similarities as well, and trying to expose it in a way that people could create a not just graph, create a flow, and say that, okay, this happened, and this was the result of all of this. And yeah, that's the takeaway that people want to figure out. So I don't know how many of you have are from security background, but something of this exists or happens even in security solutions, wherein they try to do something called threat hunting or incident analysis, and which is also a part of the SRE systems or SRE teams. But basically this is more of like bringing out things making out things easier for the developers as well. So like I said in the diagram, so we are trying to find out that intersection wherein like you have logs, you have metrics, you have traces. Say suppose you have something like a log line, a metric line, and you have a trace. You tend to find out the overlap between the events, overlap between the timestamp that is there in between all of that, and trying to find out what really happened in between all of this. Is there something that is going wrong, some other system that is causing this problem? Because as and when the new age architectures evolve and new age architectures become more and more distributed, and also like depends on collaboration between teams, like the teams building different services in different choice of languages which are suitable to their business problem. then the problem of like, different data sources, different structures evolve more and more faster. And but the only thing that is key here is the timestamp that you could correlate and measure things actually. So pretty much the last one is not exactly like a trace. It's like a select query. It doesn't look like, but trace is something like your complete programmatic inflow of what's happening in your application. So application metrics are metrics that are originating from your, or details that are really originating from your application is very much important for say your product teams or your business teams, not just ensuring your developer productivity, but also it is very useful for people who are trying to like build systems on the platforms, or trying to take decisions, what feature should be coming, what is the problems that current users are facing. So more from a functional to technical explanation actually. So I kind of like really get like I have seen the Google SRE handbook. I think quite a few people might already know about the handbook that Google has. There are quite a few interesting points and topics in this particular book, as well as a article published by Cindy. She has written a beautiful article about like monitoring and observability. There are a few points that I would definitely like to make here. Say that so basically many people generally try to configure alerts and try to figure out signals, and try to generate signals, and then try to find out what's wrong with the system. This is a regular monitoring technique, right? So but actually we all need to try to find out a fewer higher level meaningful metrics, which is really difficult. I understand, like quite a few times when I go into customer meetings or people, what I realize is it is really difficult to find some metrics for every business. So they might have few metrics, but it's not like everyone knows everything. So you need to figure out, try to do some experimentation and try to find out what are the ideal details. And also I also feel that sometimes where your DevOps teams and your the engineering teams which are building these apps on platform are quite different, you might have the problem of interrelating all of these, like the developer trying to explain what they are doing to the ops team trying to understand what the developer is explaining, and what are the difficulties in not being able to show that. So there are many things, but this is an exercise that everyone needs to do. At the same time, there is a signal to noise ratio that you need to see. Again, taking the situation of security here again, in the security world, there are more amount of alerts that can be generated, quite a few false positives that also can be generated, which is also quite common in the regular operation world. And then you might not really need to be noting all of that, but you might want to see something like, say, a disk is getting filled up, or a proxy server wherein the file descriptors are like kind of getting full, or say something like the probably the disk is going to be like worn out, or you want to analyze that sort of events and find out and do some sort of predictive analytics. So that is another way to look at things. So that is another area that you should definitely take a look at. Then there is another way. There is also one more point, if I have to tell you, that like the ability to look at all of these events and correlate and find out answers, like say what happened, where happened, why happened, like what are the different metrics between your application, between your system metrics, like real simple system metrics like RAM, CPU, and all of these. And then also sometimes some people have platforms, like say if you are running a JVM based application, you might have heap space, you might have metrics that are JVM is generating, which is a bit different from your regular system metrics, right? It is Java is a separate thing, and people might be running multiple JVMs in a server as well. So that is one another thing to look at. So if you are able to correlate all of that, that would be the basis for your effective observability strategy, or you should take all of this into content. But for more details and a very detailed explanation of all of this, the references you could go and take a look at that particular links that I have posted. I'll also share this presentation, so you can go and take a look at that. From the monitoring point of view, like again, say that if you are building a monolith, which I think nobody is doing now, everybody is trying to build a microservice, and which is okay if you are able to handle, if you are able to do and pull things. But at the same point of time, not everyone needs a microservice. For example, Elasticsearch is a very popular, Java app, a tool that many developers use. It's a monolith. We are not a microservice. Like there is no different services in the app. And even though we run on Kubernetes, there is an Elasticsearch operator for Kubernetes. But then it's a simple distributed system. And there are quite a few applications like this. There are quite a few examples. Recently, I read something, say Segment. If you know, Segment is a product analytics startup. A popular startup actually, and they have moved from a microservice architecture to a monolith. So why I dig deeper onto microservice and monolith, because there's quite a bit of interesting things that happen in this space, which also create problems into your observability or a data collection point of view, like your logs, metrics, etc. Because as and when the shareability and collaboration increases between the need for that increases and diverges more and more, your problem surface will also expand. Because say suppose I have an application which I'll show you in a minute, which has multiple services written in multiple languages, and then if I want to correlate all of this, I need to make sure that everything is in a same format. You should either come to an org standard of logging things, or you should follow a common logging practice, like say some internal library, so that everyone logs into the same thing. And as and when the org becomes more and more, the initiatives become more and more, either you ask the developer to be more restrictive in following all of these practices, or you end up having different types of log formats. Of course, you ensuring that innovation is the thing that we all want to do, right? But end of the day, it should not happen. Like it should be it's a thin line to balance, if I have to put it. So same way, so you have different platforms, different cloud platforms now. Like someone was saying, like Roland was saying, like they want to move into a hybrid model. Then how do you make sure that your OpenStack cluster, which is running internally, and probably your Azure or AWS or GCP kind of workloads, how do you correlate between them? How do you manage a Kubernetes cluster that is there here? And how do you do cluster federation and try to monitor all the metrics? So how do you ensure that take necessary actions when things are down on your person, I mean like your private cloud? So all of this complexity really becomes increasing as and when there are multiple combinations. So that's what I was really trying to explain here. So at the same time, what we observed in with different users is there is one specific tool for one specific special tool which does some specific insight into each of these data points. Say like some people might be using a tool for APM, and a tool to monitor your availability metrics, a tool to monitor your metrics, like someone was pointing about Prometheus, which is a popular metric store. And then obviously like many people store logs in Elasticsearch as well, like, or different tools actually, or services. So the idea here is to like unify all of this and try to bring into a single pane. So that is the approach that we are taking, or we are looking at actually. So when I talk about tools, like there are quite a few tools, like, and also standards. So I think me and my colleagues, we try to count the number of standards that are there today. Like say you have different tracing standards, different logging standards. Like you have open telemetry, open sensors, I mean, which some of these got merged and became a CNCF project. Then you also have Zipkin, you have Aegir, which is there, which ships out directly with your Kubernetes. So all of these are, different ways to like store and do things actually. And I mean, each tool is awesome in their own way. And but the problem for you or your ops teams is like, how do you ensure that all of this comes into a common platform? How do you do that? So that's where that's where we are trying to make sure that unify or collect data from each one of these data stores, and trying to make a common observability platform where every team can use a single pane of glass. So yeah, that brings us to the point, like the logs, metrics, APM, and uptime. Quite a few people don't talk about uptime, tracing being the very core thing for observability, and maybe logs, maybe metrics, but not availability. But I feel that availability is the king. Because for obvious reasons, if availability is up, you can at least ensure the service is up, and then you can come to probably tracing, and then you can come to probably metrics and logs. But availability is the key, and it needs to be really integrated with all of this. So I think that brings us to questions like, okay, all this is good. What you're telling is great. I'm putting questions for you itself. So what standard do you follow? Like what about data from custom applications, not from applications like, like Apache or some standard applications, right? Or servers or tools that we use. How do you correlate data, and how do you ensure that this happens easily? How do you bring all of these metrics to a single platform? So I'll try to cover some of these. I'll try to also demo this on a Kubernetes cluster. So basically, it starts from the data, definitely. So we have a open source schema project wherein quite a few partners or quite a few people have already contributed to it. It's a common schema. So this defines a structural approach to whatever you do, like what sort of data that you could, like whatever you want to do. This is not just Elastic specific. Of course, you could use this in other places as well. But this is not a tool. This is like a schema document, and quite a few people use this and like try to implement their own applications. Say there's a Spring Boot implementation of ECS where all the Spring Boot apps, Java apps, can ship out data in an ECS format, which I'll also try to show you today, wherein the timestamp is a common thing for all of this. So yeah, please let me know if you want, raise a issue, if you want to contribute, or like say if you want to look at some specific application, we would definitely take a look at that. Although like quite a few things are already shipped. And then like why we also like say a lot many times that like people say that, okay, I know that some specific, like say Logstash isn't scalable, or I can't ship data through this because it takes a lot of CPU, it does that thing, it does this thing. There are 2 points I would explain here in this session. So one is about what is coming and how it is getting better, and also like the usability of using this ecosystem projects is like it by default ships in ECS format, so that you could correlate it at your end, either in Kibana or your custom UI, because all the data gets shipped to Elasticsearch in a structured format. So APM is not in the play, but whatever the data that you are using, you could also use it in an ECM format. So ECS doesn't have implementations for, it doesn't have implementations for some Hadoop related projects, but there are quite a few like applications like Kafka. You have all the beads, you have several data stores when we are syncing data from it, and then you could ship the metrics in a common format. So there are quite a few network related systems as well. If you want to collect network related data, or they like say Cisco, Palo Alto, so they also ship this particular schema, adapt to this schema when you apply their particular modules or the implementations to the software that they have. So say that you open a specific you can open a specific Cisco software, and you can find guidelines to it as well. So that is one another thing to look at. So the logical processing pipeline that I would put you, which quite a few might already know, is like the beats to Elasticsearch to Kibana, which is and Logstash being really like the center and optional part actually here. I'll quickly go back and like see, I'll show you a demo rather than like doing stuff like there are different beats here again. So each beat is doing a specific stuff. Again, I have an improvement or something to talk about what we are doing in this space. Say quite a few people told us like, why can't it be a single beat? So we are coming up with something called one agent, so that you don't need to install multiple beats to do all of this. You can use like one agent and a different technology, a different way to push these agents to the servers or systems that you want and get things done. So I'll skip this thing and I'll try to show you the demo so that it's easier for us. Okay, great. So I have a cluster that is deployed here, and it's in the GCP Mumbai. It's deployed in the cloud platform that I have. And okay, so I have a Kubernetes cluster which is already available. So what I'll try to do is like I'll try to spin up a separate cluster, and then we can keep that cluster for the kind of as a backup. So I have all the commands snipped out. So I should have started this a bit before, maybe, so that the cluster will take a bit of time to, get things done. So let me refresh this one so that I could. So any questions in between? Like if you want to like ask me, you can, meanwhile, you can start asking me questions. You can write in the chat. Okay, great. Let me see if I could access this project. I don't know why the project is not set, but maybe because of the. Okay. Great. So basically what I want to demo here is an application, say, okay, I'll show you here something similar, like wherein I have a Kubernetes cluster wherein I'm deploying a Hello World app. And then I have the container image being shipped to a container registry of Google Cloud. And then I want to deploy that into GKE and try to monitor the logs, metrics, and also trace the application directly from it. So in the interest of time, I think, I don't know how much time we have. Yeah, we are already like near time. So in the interest of time, I'll show you what I have built in here. So I just have a 2-node GKE cluster, which is like the managed service for Kubernetes. So I have 2-node GKE cluster in which I have some specific things running. I'll also show you the pods which are there. Let me try to see if I could do that. Probably it spins up the same shell. So basically I run, I have these sort of like the pods that are running, the file beat and metric beat and other things are running as a daemon service here. And then like I have all the beats are running as a daemon set. And then I have a APM agent being wrapped up into my application, so that I could get the metrics of their Java application. So this is the app that I have. It's a simple Spring Boot security app. I don't have much code written into it. It's a simple, straightforward app. I have a simple login screen. So what I did is like I have this APM attacher. This is like a programmatic attach, so Java code. So I just attached it, and then I wrote, there is a APM application properties. I mean APM properties file, wherein I mentioned what is the the server key, server URL, and the package that needs to be traced, etc. So talking about the ECS implementation for the same, let me open this. I don't know why it's not opening. Let me open. Yeah, okay. So I have I have the logs being shipped to this particular place, and I also have a specific appender. If you are into Spring Boot, Spring Boot offers you a log back based logging system. So what I have done is like we have a Spring Boot implementation of ECS, and then I have added that particular file appender and asked to log the data in JSON file. If you are using some other appender or trying to ship with some other agent, you could still use the JSON file to like ship the data directly from this file. It ships all the events in a specific format. I think I have the cluster up. Let me also go and look at that. And this is about the Java app. It is containerized. It is pushed to the container registry. I also have the monitoring Kubernetes part, wherein I have a few specific YAML files. What I look forward to do is here create a secret first of all, and then create a secret and like expose the service, deploy the Java service, and also expose it on a IP, and then and also like create this secret wherein I could have username, password, and then I have a few YAML files which is still there. This is in a GitHub repo, so you could also go and could look at it. So I'm just stripping the data from the container and Kubernetes and all of this stuff. Now this is what is being deployed here. Now let me see if I could connect to the cluster directly and show you the pods. I don't know if there is a new thing. Okay, connect, run in Cloud Shell. Okay. there are some tmux settings that I have changed, and I think that is giving me the problem. Okay, great. I have this cluster and run in Cloud Shell, click yes. So it is created. And then if I say kubectl, I know this is not visible probably to some of you. I'll try to amplify this one. I believe this is visible. Get pods, and I have the Java app deployed here. And I'll also try to show you what sort of things are running across namespaces. So I have a bunch of stuff that is running. I try to deploy the heartbeat, which is still the container it is creating. I don't know what's wrong with it. I'll check later. But then I have file beat, I have packet beat, I have metric beat, which is shipping data to the Kibana. Because I have wrapped that everything inside, and it simply starts shipping the data. I also just put up the, the, what do you call it? I've also put up the APM agent, and through which you're able to see some, you will be able to see some traces coming from the application as well. So let me show you how the application looks like. It's pretty simple. Hope this is the one. I didn't check the IP. Otherwise, we need to check the IP. It's a simple login screen application, and okay, let me figure out. I think that's gone as well. kubectl get svc. So I have this is the external IP. You could also generate some data for us. So say if this is the one, and I have, yeah, of course, I have some basic thing. And the idea here is like if I give a specific set of password, it logs in and generates an event that user has logged in. If I don't give this, if I give a wrong username password, then it throws me error in the backend actually. So say if I try to log in with admin or some other thing, it tries to take me to that. If I use a regular official username and password, it will try to sign me in. So that's a simple application, and we generate the data for the same thing. So all this data is being shipped out to Kibana, and I'll also show you how these multiple data can be correlated. So I know there are a host of apps here, and you might also get confused here at some point. So we are trying to unify this experience as well, so that like you get what you want to see specifically. Say like logs, metrics, APM, uptime is a common apps that we have here. So I'll look it from the metrics point of view and the infrastructure point of view overall, so that we can go and take a look at everything from that place and how it is correlatable. So now I have shown you the GKE cluster. I have deployed the app. The app is running on a public internet, and then I also have I'm also trying to, the data is being shipped here, and then I'll also show you how the Kubernetes pods and everything looks like. So this is the metrics explorer, and then it has multiple ways to group things. And so I'm just showing the Kubernetes view. You could also group it by the namespace. Of course, I have two namespaces. One is deployed in like the default manner, and then the kube system, etc. So if you want to look at the logs, metrics, APM traces, and everything, I could go and look at things. Because the heartbeat is not configured, I can't look it from an availability perspective. I'll try to show another app in some time. But then if I want to take a look at logs, what's happening, there is a logs UI, which is like if you are more into like tail-f and see the log file. This is how probably you could go and look at things. So you could also stream live. I'll see. So yeah, I think I tried to log in now with the failed password here, and then I also tried to log in with admin, as you see, and that is being logged as a runtime exception, because I have written a code such that like if somebody tries to log in an admin, generate an exception. So that is the overall part from the logs point of view. Then you could also like look at log rate and various other metrics. I don't want to dig deeper into each one of them. I want to like show you the entire stuff. And then obviously you could see some metrics. There is a metrics explorer which is kind of new, new UI to look at things. So suppose if you want to see some basic metrics, say map, graph out some parameters, you could go and look into this. I don't know why this is not coming. Let me try to, okay, let me try to show you a different thing as well. Let me see if APM traces come up. Okay, good. So I have created this entire demo like today morning. So quite a few things are new here, and I'm trying to like showcase the latest data. So if you this is about the APM trace, the code that I have injected there, and using that you could do that. But then there are other ways to inject the agent as well. You could also like use the Java agent from the JVM perspective options, and also like inject and get the data without changing any code. That is also possible. You just need to add in the JVM options config file quite a few details that are collected here. And again, from here, if you want to see the logs of container, trace logs, and metrics, also see sample documents, want to go and to look into that. So you can do all of that as well. Something I cover anything that I forgot. Okay, so there is a service map feature as well, which I think I don't have, which will come, because maybe I might be running an old cluster. So if there are any specific errors, okay, yeah, so it will automatically catch and log errors, so that you could go and look at the code, you could look at different things. All of that is as possible as well. So that is about APM. And yeah, so one more thing that I forgot to explain is like, so you could also configure various modules with Kubernetes. Say suppose like you are running a microservice based app, like say your front end is in Node.js, and probably you might be running a cache layer like Redis, and then you might be running a MongoDB and a relational DB, and also multiple stuff like this, right? So what you could also go and look at here is there are dashboards which are automatically generated, so that you don't need to go and specifically look at for each of these. So you just need to enable that module, and the data automatically starts flowing in a structured manner because of ECS and several other things, because we know what things are going around. I'll try to show you something here. So in the config file, if you see that I have given the input as a type container, and I'm adding Kubernetes metadata, and also I'm adding the cloud metadata and host metadata, which shows that where the app is running, which region, so that you have multiple dimensions to query, and you have multiple options to like graph it out if you want to graph. So there is a change here. So suppose if you want to see that, you want to attach and prune all the, I mean, get all the logs of a specific system. Say you have a MySQL server, you want to find all the access log and query log of MySQL. There is an option to auto discover these things in Kubernetes. You just need to write some YAML file which say like, if this matches this particular thing, try to attach this module, and then it automatically logs. So it's just your file beat, and you know that what containers would come up, right? And all the containers which doesn't fall into this matrix will still be coming into your regular Kubernetes logs. I'm sorry, I'm not seeing the chat window as of now, but I will try to come back and answer all the queries there as well. So yeah, let me see if I could see the logs or file beat. Kubernetes. So there are quite a few things that I do. So that's why the demo system is a bit different here. Kubernetes and okay, overview of cluster metrics. So this should come. So I have started to collate the metrics from each one of them last week as well. So let me see if there is anything different in the last week. So I don't know why it is not coming here, but let me see if I could. Yeah, there is some stuff, but I don't know still why zeros are being shown here. I have seen some metrics. So you get all this data populated automatically into when you start doing this file beat, metric beat, packet beat YAMLs, and try to push data out of it. There is also alerting in each of this app, so that you could start writing alerts directly out of that place in the actions that I shown at each place, and then you could go and look at these things. That's it about my demo. I'll show you some more things based on other UI that I have. So this is a basic app that I have done today morning, but there are complex apps, like say, you know, when you have a microservice system, you might have multiple things like this, right? You have especially in an e-commerce system, there are multiple things and multiple services. So we have a observability platform internal, like we run a demo platform which are infra run. So this is how that one looks like, and I'm trying to show you the namespaces and the various things that are there, and also try to show you from an uptime point of view. Say that if I have this particular thing, and if I want to look at the metrics for this particular platform, I'll be able to see when it is up, when it is down from an availability point of view, and come to the logs part later point of time. See, I think this is down in this particular time, and then I'll be able to go and click and look into more details. But then if I don't want to do that, there's already a search bar, so I'll be able to go and look at these things, and I'll be able to see what is wrong with each one of these endpoints, etc. We also monitor some other things to generate that data, but doesn't mean that we have things, agents or something that is being installed. It's just like an heartbeat can be run on any server, and you just need to give an YAML file, and then it will simply start doing ICMP, HTTP, ping kind of a thing. Actually, if you have seen some sort of a SaaS service similar to it, it's more or less the same. So yeah, this is again mapped on a time frame, and you could go and look at various things actually. So yeah, so that's about the demo, and I'll quickly come back and want to take more questions about the demo, but I want to also talk about some best practices and things that people really worry about when they think about Elasticsearch, but they think also about a memory hog, and they think about a lot of data being ingested, cluster getting filled, shards getting so many shards, and there are a lot of operational headache that people also think. So as part of it, over the last 1.5 years, we made quite a few improvements into each one of this, but it is not as popular as the general things that are very popular. So there are quite a few things that are in Elasticsearch world that people follow, but then that there are things that are not known, which we want to explain to everybody. So say that there is a specific API called rollup, which can roll up your data, and by collecting some generic insights and keeping it to a specific index, and discard the data or delete or move it to a different platform. So rollup is one such place, and we also have a UI in Kibana for rollup. Please go and look at that. It is there in the management part that is there. Then you also have index lifecycle management policies. Say that suppose that if you want to roll over the data and remove the data and move into multiple indexes or different sort of hardware, delete, say that is another best practice that we would definitely recommend. All of this can be this by default enabled and integrated when you use Beats and Elastic ecosystem things. But if you don't use, or in the Stack ecosystem, if you are shipping the data from your custom application, which is also pretty common, you could leverage this and create this. But I would definitely argue that don't look it from the point of try to do it by yourself. Try to leverage the automation as much as possible, so that you don't need to worry about it, and it automatically takes care of that. And then obviously there are best practices in terms of what hardware could be chosen, and like what sort of things that can be put at, like say quite a few people store logs in Elasticsearch, but also like as and when the logs become TBs and PBs, they tend to feel that, okay, I don't want all the logs in one place, but I still want to have the queryability capabilities, but at a reduced space. So these are the different tenures of data that you could store into each one of this place. Say hot is something that I'm just giving numbers, but this can be different for each person and each organization. So in my view, like hot can be something like 7 days, and warm can be something like 1 month or 1 quarter, and then people shift that warm data to cold. So your hot and warm share, hot might be sharing some good amount of data, decent amount of data in recent times, and then your warm might share 50 to 60% of data. So when I say hot and warm, these are backed by your your infrastructure templates as well, like say your SSDs in terms of hot, and you have specific compute instances in different cloud platforms, VM profiles, what they call as. So say something like i3s, M4, C4s, R4s. We have a blog article, again, I'm sorry I didn't link it here, but we have a blog article mentioning that. Or you could go also look at the cloud platform and see what are the templates that we use ourselves. So also you could use if you want to spin up on a different cloud. And then you have cold and frozen things, and then also snapshotting the data when you won't want it. So there are more and more new things coming. The cold nodes can also be like queryable, and also the frozen indices. We also introduced something called frozen index, which is still searchable. That means it still takes less heap and less memory. It is kind of your not really taking your majority of your cluster load, but it is still searchable at a lesser time. There is also a feature that is coming in wherein you could run a query perpetually. Say you have a TB of data and you in a Kibana, and then you want to run a query, but the query times out. Really a bad experience, right? Probably. And then you just want the query to show up how much ever time does it take, but you just want the query to happen. So this is something that we have implemented, and we are gonna kind of make more advances in that area. It's called Async Search. So you could also schedule or ask a search, and search runs backend, and it will show you the data when it is available. It will be relatively faster, but it will not be time bound by what Kibana or somebody else would say. Because searching on Elasticsearch sometimes, because it indexes a lot of these things, because it makes the data ready when you are indexing the data. So that's why it's a bit faster. So you could still leverage that, but you could we could query a lot of data as well. So it's kind of doing that sort of a thing. So this is where you are even though you have data and some lot amount of data in frozen index, you can also try to search and do stuff like that. So yeah, that brings also to the last part of the talk, what is getting better, and what are the things that are becoming easier, or what we are doing with respect to integrations, etc. So there are 3 or 4 things that are coming in here. Say I spoke about single agent, because quite a few people find it difficult. Why should we there are multiple software for the same thing? So one agent is something that we are really looking forward, and it's kind of on path, which will come very soon. And then you would also see very soon something called an ingest manager, so that you could ingest data and very quickly, easily, just like how you think of Kafka, you could think of similar sort of way with Elasticsearch as well. There is a project called Elastic Fleet, through which you will be able to install the agent, just like from Kibana. You will be able to install the agent and push all the data, pull all the data, just like how Logstash would do in an automatic process. I think I skipped some slides which is there in between, which shows some of this, and which shows some of this, that is the overall things, how it is going on. But I also have some more slides so that you could also see some of these views. We also building something like a package registry. These modules have really become famous, and quite a few people in the community use these modules. So contributing these modules have become a bit easier, but we also want you to leverage and install these whenever you want, enable, disable things. So we're building something like a package registry, which could also be something like your npm for Node, so something of that sort. So this is how the package manager would look like, so that you have a bunch of integrations for logs, metrics, and different things. So very, very early way to look at things. There are things that are getting changed and doing stuff. So yeah, here is about Nginx. How do you do all of that, and configuration, installing the package. When you click on install package, we think that it directly gets installed on the infrastructure that you have according to the policy that you have set in the fleet. So yeah, this is how the fleet looks like. You might have multiple fleets, multiple agents, and then you might want to do all of this. From the point of data, we try to look at look at multiple things that are happening in the cloud world, in the cloud native world. I mean, cloud native computing foundation projects as well. So two things that are very obvious is like Prometheus, which is a very popular metric store, and we really like Prometheus, and we have integration now for the Prometheus. If you are having metric stored in Prometheus, because you might be running Kubernetes, and like we have a natural integration so that you could also bring in that data. It's a normal simple Prometheus module that you could simply enable, and like you can get data. Then we also have Jaeger traces integrations. You don't need to install any agent. If you have a Jaeger integration already running, a pod running in Kubernetes, why do you need to install agent? So we also honor Jaeger traces that are coming through APM server, and it will be ingest into Elasticsearch. The same UI, same dashboard, same things will be honored, and like you will still have all of this. So some of these is already available, like say Prometheus and Jaeger traces integrations are already there, but there are more and more things coming in as in more and more releases have. I know that Roland was saying that PromQL is something that they really like. So Elasticsearch has a specific query DSL, which also is there's a bit of learning curve to learn that. But then we also support SQL. There is a upcoming support to do EQL, like end game query languages, more of for security reasons, or seeing more things. We also look forward to support PromQL, wherein you could do the same sort of operations that are there on the PromQL as well. I mean, using PromQL, you can query the data that is there in Elasticsearch as well. So that is something that is in play. I think I did talk about all of this, like the alerting and multiple integrations with different systems. Okay, I think some of this is not mentioned here. I think I also run a very old, I run 1 or 2 versions back in the cluster. So the upcoming version will have, viewing the logs in the context, what's happening with specific key value pair, more details on the log UI, the streaming logs that I shown you previously actually. And service maps have come. I spoke about it as well. So how do you stream all of this data? And then real user monitoring, which is already there, but I think there needs to be a lot of improvement that we also look forward to do in terms of like the end user monitoring, say how the application is working, because there's quite a few companies which use something like React Native or JavaScript frameworks, new age JavaScript, good framework, so that like you could pull out the data and like find out things, do more functional or product specific analytics. So that is one another thing that is coming. That brings us to the end of the talk. I'll update this URL. Currently it is pointing to something else, but I'll update with this, the presentation. I'll update with the GitHub links that I have that I used to create the demo. I'll update you with more and more stuff related to that. Any questions?
Thanks, Arvind. There are a couple of questions. Rather than me reading them out, let's say if the people are still here. Ankit Sharma, do you want to go ahead and ask your questions yourself rather than me reading them out?
Sure, I can do that. Thank you. So, Arvind, so now I have been running Elasticsearch past several years now, mostly for logging. And what I see is the total cost of ownership of these clusters is quite high as compared to other solutions. And then because now when you try to integrate observability into it, which includes adding data from other points like tracing and then metrics and all those things. So what I believe is that the cost will, again, it will go more higher. Okay. And again, there are, challenges maintaining the Elasticsearch cluster in itself also. Like it's quite costly to maintain as well. So, keeping all those facts in mind, how does observability on this entire ES make sense?
So I think I showed you some, some ways that you could manage the data. Number one, I don't deny the fact quite a few people will quite a few who are in this meeting as well. I've had discussions with them previously, like wherein there is a lot of data coming in, and it's getting difficult to manage because it is a straight linear scaling. They add one more node and one more node and one more node as the data becomes more, and so that you want to keep the same query speed. You keep adding more compute to it, and then the cost of the infrastructure and maintaining this and putting all the data, managing the data gets difficult. So may I ask, like, what sort of approach that you have having? Like, are you running a managed service of Elasticsearch, or are you running a custom cluster that you have built on something like AWS or some cloud platform?
It's a custom cluster
Yeah.
on AWS.
So like I said, there are quite a few improvements that have been made. So I would like you to take a look at these. Say if you're having more overshadowing problem, like more data. So what you need to do is, like, you need to pull in all the data, and you need to do the roll up and keep the insights and throw away the data that you into the cold storage part. That simplifies the stuff. Then if you are looking at, like, say, ingesting, if you are looking at scalability related issues, then it comes to the point of, like, what sort of hardware templates you use, the infrastructure cost. Even though whatever I spoke is completely open source, like free and open, I didn't talk about anything paid here. So even though it is open source and very easy to consume, which quite a few people use, what happens is, like, the kind of cluster template that you use also makes a lot of difference. Say that if you are using SSDs for some, like, hot warm type architecture, if you're building an observability platform, we recommend hot warm architecture. So something of that sort needs to be planned out as well, so that many people wouldn't do, and it's a simple straightforward clustering. So all of these needs to be taken into consideration when you are creating this entire system. But when you are going to some managed service, like, say, running Kubernetes yourself is different. Running something like a managed Kubernetes service is a bit easier for you to look at what you want to do. So running managed service is another way, so that you could go and, like, kind of improve things in that manner. Something that you could think of, from the point of, like, strategy. If I look at things, there are quite a few people who want to do cross service and cross event correlation from different services. Like, say, they have your system metrics, they have your logs coming from your system logs. I'm not even talking about application log, right? There are application traces. All of this data they want to ship into a unified platform, and they want to have a single pane of glass to pan out everything. And then they have they have multiple systems, old systems, legacy systems. So how do they do all of this? So that is where they are seeing value in adding that. But then if you could follow the ILM, the index lifecycle management policies and rollups, it becomes really easy. It really becomes easy. So I have seen quite a few people take leverage of that system. I think I would advise you to do that as well.
Okay.
But we can discuss about it. So you could always write to me. I think my email is here, and you could write to me, and I would be happy to help. Yeah, or even DM me.
Yeah, I will get in touch, because the things that you have said is, like, it's more generic, but when we come to a specific use case, then how many hot indexes do we want? How much of data do we really want all the time in the cluster, which is searchable? So all those things vary use case by use case, right?
Yes.
So
that's also a problem with Elasticsearch in a way, because you need to tune it for the use case, and you might also be having multiple users, multiple apps shipping data. So a lot of things to discuss. And this is not an architecture session. This is just what is happening in the observability.
I agree.
I would love to do it at some point of time, which I have done. We'll do it definitely. And there is one more question, I think, Ankit, from you, is it? APM is supporting.
Yeah, I have two more questions. So one question is, like, APM, as you showed us, you showed the integration with JVM. So what else does it support right now?
APM also supports a bunch of other languages. I think there are 5 or 6 languages we support: Python, Perl, Ruby. There are quite a few. I think, let me go and we support all the major languages except PHP, which is work in progress. .NET is also supported.
Okay.
There are logos here, but all of these are supported. Like no JavaScript also is there. You can do all of that. Yeah.
Okay.
And all of them are GA. There is not beta or alpha kind of a thing. All of them are GA.
Okay. Just one last question from my end. So can we actually use Beats without using the default backend as Elasticsearch? Can we use other backends as well? Last time I
They
checked,
need
it
to
was
change the
not there.
code. They need to change the code because the Beats by default ship to Elasticsearch, but you can also ship to Kafka, I believe. Just see how, and you can consume from Kafka. Just take a look at that because we have a Kafka input.
Okay.
Kafka output, I think we have a Kafka output so that you can give the output to the Kafka because quite a few people want this thing to happen. So like you could also use it that way.
Okay.
Yep. So even at
Thank you very
Grab,
much.
like some parts of Grabs, we do use Elasticsearch majorly for our logging infra as well, right? So we use similar setup, let's say, especially on the mobility side where FileBeat ships it to a Kafka cluster, which we use as buffer. And from there on, it gets ingested into the Elastic clusters.
Oh, okay.
So the data that is shipped here is quite, it's quite suitable to Elasticsearch. So if you want to use another thing, you need to make sure that what is the resulting data stores structure, what works well, etc. One thing that I forgot to tell you here is like some people were telling about Loki kind of a thing. You could still do the same sort of a thing by not indexing because Elasticsearch index all of the labels as attributes. You could also choose not what to index and index only things that you want, and you could also query it that way. That's another way to look at things. Yeah. One more question from Randhir, like what layout do you recommend, pattern or JSON layout? I quite couldn't get that.
Randhir, do you want to explain your question? I think you're still on the call.
Yeah, so my question was, when you use logback.xml in your Spring application, you might have specified some pattern, right? Logging pattern, or it could be JSON layout, where the fields order don't matter. Timestamp could be at first place or it could be at last place when you serialize the JSON. So my question was, if I have Kibana integrated in my application, then JSON may be fine because there is a parsing of log. But if I don't have this Kibana, and if I have to just read the logs in JSON format, then it's not very readable, human readable.
Okay, I'll stop you there because I think we are not doing that. Let me kind of, I don't know. Okay, let me quickly click on the Cloud Shell. Okay, so basically here I have the data being shipped in both the places, not just the not just in a JSON format. It is being shipped in all the types. So suppose kubectl exec -it. I think I could show this thing to you. So what happens is here I do have the data being logged in. Okay, it's showing something. I'll try to explain you here. The data being logged in both JSON as well as .log. So if you see the log in the application properties that I mentioned, it is shared like spring.security.log. The easiest format to put it in JSON is just a convenience. Some people might want to directly see it in log, and then you might want to ship. If you are using FileBeat itself, it will not do JSON in JSON. So it will automatically ship that JSON itself. So here with all the things happening there, I still have this one in a simple line format. I don't have JSON in JSON, but if I go to the discovery part, I'll see the probably the log in a escaped format. Like all the new lines and everything are escaped in a specific format. I think something wrong. Okay, so that is there as well. Maybe I need to use.
So you recommend logging in both?
You can use, if you want to use this one and directly ship, you can do that. So which I recommend, because this is more structured approach. You ship the data in ECS format, just put this file .yaml, it automatically ships your structured .log file to Elasticsearch. Okay. No, if you don't want to use FileBeat, but still want to leverage, if you don't want to use FileBeat as a data shipper or something like FluentD or some other thing, like say you are using a different orchestration engine altogether, and then like Docker and something else, then you could simply ship this JSON file, again store in Elasticsearch. So both are possible. So it's up to your choice. What I've done right now is, even though I put as JSON file, I'm still shipping the regular log file only to Elasticsearch. The log is only getting shipped, but JSON is also getting recorded. Both are possible.
Okay.
So this is the dependency to add, and this is the log. I mean the appender to be added.
Yeah, got it.
Okay. One other question. What is that? So Debansu, you have asked a question. You want to?
Yeah, no. So I was just checking whether those your roll-up policies are those separate clusters.
Yeah. So yes, that's how it is. It can be separate clusters. I mean, no, sorry. You meant to say separate cluster. I'm saying separate nodes, not separate clusters. Say it is not like your hot is one cluster, warm is one cluster. No. It is in the same cluster. Nodes are divided into multiple types: warm, hot, then then like cold and all out of this. Let me try to show you the template, and then so that you could figure out what is it like. I'll show you one template here, so that in the same cluster you can do it, but then you can also do something like cross cluster replication with Elasticsearch, through which you can connect multiple clusters. Actually, say if I see hot warm here, I have the coordinating nodes, I have some high IO instances with respect to some 4 GB RAM or something like that. Then I have different templates of hardware, different hardware templated instances. I am trying to group them into multiple things and trying to create a cluster here. So this is what ideally everyone should look at when they are trying to look at their use case. You have logs, metrics, APM traces, all time series data. You need to group it in this format. And then you have something else like search related thing. Then you need to group in a different format. So that is how you can say Elasticsearch is like a raw engine. You need to build this like clay. You need to clay it out properly, and then it will work really well. I have seen a non-customer shipping like say like 30 TB data per day, and then it still works, and they have reasonable amount of nodes. They don't have like some 200 300 nodes. It's like some 50-60 nodes, and they're able to manage all the data, remove all the data in time for every 7 days, and they're able to quite comfortably do all of this very easily. So all of this is in different nodes, and simply to put in Devansu.
Okay, thanks. Thanks.
There is one more question. Say, do you recommend ECS formatted logs to be written out to the STD in terms of the control? Yes. Right now I'm doing that. Say, my Java application. I just didn't mention anything specific. I mean, even though that log is there, you can always log it to the console and let the thing pick up automatically. So see, ECS just is a structure, way to structure things, but it is not. Your choices of shipping data is always available. But when you use FileBeat, what happens by default is if known sources are automatically structured into ECS, unknown data sources are tried to be structured into ECS. If you know what to be done, you can specify it and you can leverage that model so that you can correlate at the end. So you can correlate at the end, say like if somebody has an IP address, if you take IP address as a dimension and say everything related to IP address in that data. So that is quite easy for you to write, like coming from a different systems. Okay, great. I think that's the end of questions. Girish, I think, did I answer? Yeah. Any more questions? Great.
Okay, so I think for the sake of time, we need to wrap up. Anshu, would you like to go?
I guess first and foremost, thanks to everyone who joined. Right, thanks to the community for joining us. Thanks to Roland and Arvind for gracing us with their talk today. I think it was definitely helpful. we had a few more questions. Folks have left, but yeah, Roland will be answering them as part of the slide and doc and sharing them afterwards. So it's definitely a novel experience, right? I think all of us have been doing various calls ever since we have been working, but yeah, they were more along the line of, hey, because we are in Bangalore, others are in some other city across the world. And it's a different story that, hey, Devanshu is sitting in, let's say, I think 5, 6, 7 kilometers away from me. I think everyone around here will be within the 5, 10 kilometers radius, and still we are here sitting and talking. And I don't think this is going to change anytime soon, right? We might be back in office, let's say in the next couple of weeks, but I'm not sure if we will be able to organize even our scale meetups where typically about 60 to 70 people turn up for in-person events per quarter. I'm not sure if we will be able to do that at least this year anytime soon. So we'll keep assessing it on an ongoing basis, and let's see how soon can we get back to do in-person sessions. But till then, yeah, we'll continue doing these virtual events. So yeah, thanks folks again. Thanks Devanshu, Srinivas, and all the folks who have joined us, who kept joining us in person, and who have again joined us. I think I remember seeing a couple of older known names and faces earlier in the call as well. So yeah, that's it from my side. Devanshu, yeah, over to you.
Thanks, Anshu, for hosting it. First of all, coming up with the idea that we should now start doing a virtual event. This was a conversation you started. We are missing something. Obviously, we are missing the in-person chit chat, then the lunches, then the goodies. All these things are missed, and most important thing, the photographs are missed. So I was able to take some screenshots, which I'll probably add to the community. But at least for few future meetups, we'll do like half day because as you may have understood, like doing it full day is in this mode may not be very good. So we'll try to do half day events and few more frequent one. We're planning to come up with June is in schedule actually. So we'll try to do June as well as probably in August. Depends on the availability of speakers. That's all. That should be that's the near future of LSPE in meetup community. One good thing which has happened is earlier we used to have challenge in recording our events. Now these events are automatically recorded. For last 8 years, the recordings were sparse, not published. Now this is automatic. So something better than the previous sessions. So missing something, additional something, we are all good.
Yeah. So right now it's on my personal YouTube stream, but yeah, we'll see if we can move it to a dedicated channel. But yeah, it's already open. That particular link is public and will remain open forever. So yeah.
Great, everyone. So have a nice weekend, and let's close this 30-second LSPE in meetup event, though virtual this time. Thank you.
Thanks, Devanshu.
Thanks all. Thanks a lot. Bye-bye.